trick to find reciprocated partial derivatives. Now, what's partial derivative? Okay, so I'll tell that first. So in this problem, we are basically given the equations for x, y, z, right? We are like given the equations that can help us transform. Sorry, that can help us transform the x, y, z coordinates to theta, phi coordinates, right? And okay, so first of all, I guess you know like how to find partial x by partial r, right? Because x is given in this other world of r theta phi. You can easily find it, right? That will just be differentiate this with respect to r, assuming all others are constant. So this will just be sine theta cos phi, right? Similarly, partial y by partial r will be sine theta sine phi, right? Because all others are constant except r is the variable in while doing partial with respect to r. Now partial g partial r is just cos theta, right? Now we can find this easily. Like similarly, if you want to find out, let's say partial x by partial theta, that's also easy, right? Just assume theta is variable, others are constant. So this will be r cos theta cos phi, right? This one is easy, but here in this question we have to find reciprocal partial r partial x, not partial x partial r, right? So how will you find this? If you are thinking that the partial r partial x is just inverse of partial x by partial r, then that's just wrong. Because I'll give an example. Let's say if let's say x is u plus b, y is u minus b. Yeah, let's say this is the equation that transforms xy coordinates to b coordinates. Then in that case, u will be, if you sum these two, x plus y by 2, right? If you subtract these two, b will be x minus y by 2, right? Now over here, partial x by partial u will just be 1, right? But over here, partial u by partial x is half. So you clearly see that they aren't equal. There's definitely some equations like that relates these two, which we will discuss in a slightly 5 or 6 minutes later in the same video. But for now, what we will try to do is we will try to find equations of r in terms of x, y, z. We will try to find equations for theta in terms of x, y, z. We will try to find equations of phi in terms of x, y, z. And if we find that, then we can easily find out partial r by partial x, or partial theta by partial x, or partial phi by partial x, or partial phi by partial y. This is our first approach because this is more practical, right? And after we get answers from this approach, we also have an approach like to directly relate these two. So that's what I've been calling the trick in this video, and we will also give proof to why that trick works. So we'll do all of this in this video, but first of all, let's try to find r, theta, and phi in this in terms of x, y, z. To find that, first of all, you need to visualize these coordinates, right? Now, you need to like visualize how these are actually working, right? Okay, so let's say I have a coordinate system of x, y, z. This is x, this is y, this is z. Let's say here's a point in this space P with coordinates x, y, z, and this is the projection of this point on the xy plane, right? And yeah, and so these are the xyz coordinates of this point. This is the x coordinate of this. There it's x naught, y naught, z naught. Or let's just say xyz. Like it makes sense anyway. Okay, this is the x coordinate of this point. This is the y coordinate of this point. This is the z coordinate of this point. Right. Now, let us say that r be the distance of this point from the origin. Let us say that r is this distance from the origin. Let us say that okay, for this point, this is the projection of this point, right? This is the like projection of this point, right? Now let's say the projection of this point makes an angle of phi with x-axis. This is the projection of this point which makes angle phi with the x-axis. So, and this r, there's the position vector of this point let's say it makes an angle theta with the z axis. Yeah. Now in this case, if you just use some trigonometry, so okay, so this point is in like space, right, and it's making an angle of theta with the z axis. Now definitely this is a right angle, right? So because this should be perpendicular, right, and this is the right angle, then you can clearly see that our okay then this is the z coordinate, this is the length of y coordinate, this is the length of x coordinate, right? Now z coordinate will just be r cos theta, right, because that's just the projection of this point on the z axis. And similarly our length of this, this length, the length of the projection, let's say that's L, that will just be r sine theta, right, because this projection will just be equal to this length, and this length from the triangle is just r sine theta. Now if we know that this is r sine theta, now if you want to find x, we know that x is just L cos phi, right, but again L is r sine theta, so this is r sine theta cos phi. Similarly y is just L sine phi, right, because y is just this length, right, this y, and this length from the triangle is sine phi. So again L is r sine theta, so this is r sine theta sine phi. So from here we see that in this setup, if the theta is the angle made by the position vector of the point with z axis, phi is the angle made by the projection with x axis, and r be the distance of the point from the origin, in that case x would exactly be r sine theta cos phi, y will be equals to r sine theta sine phi, and g will be equals to r cos theta. Okay, now we got that where these coordinates come from, and like such a way of making coordinates is also called, such a way of writing coordinates in terms of r theta phi is also called spherical coordinate system for some reason which you can explore on your own. Okay, now the reason is actually, if you like let the r be derived from like 0 to some length a, theta be derived from 0 to 2 pi, if you let the phi be derived from 0 to pi, you will exactly get a sphere, so that's why it's called a spherical coordinate system. Okay, now now the benefit of this, like making this setup, is that now we will be able to express r theta and phi in terms of xyz. So let's do that. Now from this figure it's obvious that r square is equals to this, r square will be equals to this L square plus g square, right, L square plus g square. Now again this L square is just equals to y square plus x square, right, so this is x square plus y square plus z square. So our r square is just x square plus y square plus g square. We got this, right, the equation for r. Now similarly for this theta, the theta is just tan inverse of, this is L by z, right, so tan inverse of L by z. You see that, right? So theta is just tan inverse of L is square root of x square plus y square by z. So we got theta also in terms of x, y, z. Now if you want phi will also be tan inverse of, this is y, this is x, right, tan inverse of y by x. So we also got this in terms of x, y, z, right? There's not z, but still, yeah, we just need any one of those three. Okay, now we got this using the visual system. You might also you could have also got that using algebra, right? If you could have just tried to add these squares, and that would add up to r square. You could have also used some algebra, like if you add the squares of these two, sine square phi plus cos square phi would get cancelled out, and this would just be r square sine square theta, r sine theta. There's r cos theta, you could have found tan theta. And also for this one you could have used these two coordinates, and then you could have got like tan phi. So this is also this is also intuitive algebraically as well, but yeah, I give a visual idea to make it more clear. Now we have this equation. Now we can definitely find these. This is not hard problem because we have r expressed in terms of x, y, z. So now we can definitely find partial r by partial x, right? Similarly, from here, partial theta by partial x. You can find any of these things. So yeah, let's try to find it out. Phew. Okay, now first of all, and notice that we just need to find in terms of x and y only, not in terms of z, right? Okay. So first of all, we have this, right? Let's start with r square is equals to x square plus y square plus z square. If we make a partial differentiation with respect to x, what we will get is this will be just 2r times partial r by partial x. This will just be 2x and others are constant, so 0 plus 0. So partial r by partial x will just be x by r. You got that, right? Now next one. Again, we have r square is equals to x square plus y square plus z square. If you make a partial differentiation with respect to y, this would just be 2r times partial y by partial y is equals to 2y. So partial r by partial y would just be y by r. Done, right? Okay, so we are done with these two partial. Okay. Now next one. Now for the next one, we know that tan theta is square root of x square plus y square. This square root might make our deal a bit difficult, but yeah, we'll definitely do it. Now this will be sec square theta and then partial theta. Let me write partial diff with respect to x. Partial diff with respect to x. So sec square theta partial theta by partial x will be equals to 1 by z times 1 by 2 root x square plus y square, right? First of all, this is square root. 1 by z is just constant. And now the inside thing. So that will just be 2x plus 0. That's just 2x, right? This cancels out. So we have partial theta by partial x is just x cos square theta by z square root of x square plus y square, right? Now if you want to simplify this in terms of xy, first of all, let us write all of these in terms of spherical and then again simplify back to xyz. That will be helpful, I guess. Now we know that this x is just r sine theta cos phi cos square theta, right? And now this g is just r cos theta. This is just r sine theta, right? Sine theta cancels out. One of the cos theta cancels out. R cos cancels out. So this is just cos phi cos theta by r. This is our partial theta by partial x. Guys, actually, what I think is the source which I'm like consulting right now for the answers, that actually has all of these partials in the polar form. So let me change all of this in the polar form. My x by r will now just be sine theta cos phi, right? Let me also take the answer side by side. Okay, wait, hydrogen 25221. Okay, let me also consult the solution. Not solution, the answer side by side. Okay, yeah, this is sine theta cos phi, that works, and this is sine theta sine phi, that also works. And now this is cos phi cos theta by r, that also works. Now next one is we need to partial differentiate with respect to y, right? So we have tan theta is equals to square root of x square plus y square by z. Now if I make a partial differentiation with respect to y, what I will get is this will be sec square theta partial theta by partial y will be equals to 1 by z will be constant, and this will be 1 by 2 root x square plus y square times 2x, right? Is it? Yeah, sorry, no, it's 2y because now x is constant and y square 2y. Okay, now 2 cancels out. Now partial theta by partial y will just be y cos square theta z square root of x square plus y square. Now let's try to write this in terms of polar coordinates. I mean, not polar, spherical coordinates. Now y is just r sine theta sine phi cos square theta divided by g is just r cos theta, and this is just r sine theta. Sine theta cancels out, cos one of them cancels out, this cancels out, so we get sine phi cos theta by r, which is exactly what's given in my answer key as well. Sine phi cos theta by r. Okay, good. Now we have, I think we have a few more. For phi, our tan phi is y by x, right? Okay. Now if I try to differentiate this with respect to x, so partial differentiation with respect to x, I will have sec square phi times d phi by dx will just be minus y by x square, right? Minus 1 by x square, and then partial phi by partial x will just be minus y cos square phi by x square. Now let me write all of this in terms of spherical coordinates. This is minus r sine theta sine phi cos square phi divided by r square sine square theta cos square phi. This cancels out. One of the sine square theta cancels out, one of the r cancels out. So d phi by dx will just be minus sine phi by r sine theta. Minus sine phi by r sine theta. That's it. Yeah, that's right. And now last one. Tan phi is equals to y by x. Now if we make a partial differentiation with respect to y, you get sec square phi d phi by dy will be equals to 1 by x. D phi by dy will be equals to cos square phi by x. So d phi by dy is equals to cos square phi divided by r sine theta cos phi. One of the cos phi get cancels out, so this is cos phi by r sine theta, which is our d phi by dy. No, not d. This is partial. This is just partial, not complete differentiation. Partial. Okay. Yeah, cos phi by r sine theta. Okay. So all of them are right, and this is how you can do all of them just from intuition, just from the figure, right? Now let's see an alternative and shortcut way. So first of all, I will just give you the formula, just the trick, and then we will find the values using the trick, right? And it's at the end of this video, at the last, then only I will give you a reason why the trick works. Okay. First of all, we will just use the trick, and at the end of this video, we will find out why the trick works. So that's how it will go. Okay. Now, first of all, what's the trick? The trick is okay. So if you want to find that matrix of partial r by partial x, partial r by partial y, partial r by partial j, how this partial r changes, partial theta by partial x, partial theta by partial y, partial theta by partial g, how theta changes, and partial phi by partial x, partial phi by partial y, partial phi by partial change g. If you want this matrix of how r changes, how theta changes, how phi changes, this matrix will just be inverse of this matrix. How x changes, how x changes, how x changes, how y changes, how y changes, how y changes, how z changes, how z changes, how z changes. It will just be its inverse. I'll give the reasoning at the end, but for now, just understand how this matrix is made. This is in matrix. This is about change in x, change in y, change in z. This is about change in r, change in theta, change in phi, right? Now, this one will just be its inverse. So, and it's easy to find the elements of this matrix, right? Because our equations are already given in terms of x, given like biology of x in terms of r theta phi. So it's easy to find this matrix. Just find the inverse, that will be equal to this one. At the end, we will discuss why this works, but for now, let us apply this, right? Okay. Now let's try to fill this matrix. Let us try to fill this matrix. This matrix will just be okay. Now we'll try to deal with this matrix, guys. Okay. Yeah. So I will just find its inverse over here, and then later on we will compare it with this matrix and find all the partials. Okay. So this will be, what is partial x and partial r? Just sine theta cos phi, right? Sine theta cos phi. What is partial x and partial theta? That's just r cos theta cos phi, right? R cos theta cos phi. What is partial x and partial phi? Minus r sin theta sin phi. Minus r sin theta sin phi, right? Okay. Now what is partial y by partial r? Sin theta sin phi, right? Sin theta sin phi. What is partial y by partial theta? R cos theta sin phi. R cos theta sin phi. What is partial y by partial phi? R sin theta cos phi. R sin theta cos phi. Okay. What is partial g by partial r? Cos theta. Cos theta. Partial g by partial theta. Minus r sin theta. Minus r sin theta. Partial g partial phi. Partial g partial phi. That's just theory because there's no phi in it, so everything is a constant. So yeah, we need to find its inverse, right? And now to find its inverse. Finding inverse in itself is a long process, but yeah, it's not that hard. This might get complicated because there are a lot of variables, but yeah, we'll do it, guys. Don't worry, we'll do it. We'll do it. Okay. Now, first of all, let's find determinant. Okay, because we definitely need that, right? So I will find determinant over here. Determinant over here. So determinant will be, first of all, take sine theta cos phi, right? Take sine theta cos phi, and determinant of, and then determinant of, I guess you know, I think you know, guys, determinant of this, right? Yeah, with this one. Okay, so let's do that. I guess all of you know that thing from your high school. Okay, so that will be 0 plus r square sine square theta cos phi, right? Now there will be minus, and then second one, r cos theta cos phi. Now in this case we will not look at the row and column where this is, so we will take determinant of the remaining elements, right? So I guess you know that the determinant of remaining element, this will be 0, and then minus r sin theta cos phi, right? R sin theta cos phi. Yes, good. Now again plus. Now that thing is already negative, so minus r sin theta sin phi, and then this will be minus r sin square theta sin phi minus again r cos square theta sin phi. Guys, that's a good thing for us because they will add up to 1, right? Okay. Now this determinant is, it will just be r square sin cube theta cos square phi, right? And then plus r square, this is cos square theta sin theta cos phi, right? Cos square theta sin theta cos square phi. Okay, good. Now this is Okay, this minus will be plus. There will, from here, basically this sine square, if you take minus r sine phi common, sine square theta plus cos theta will be 1, so there will just be minus r sine phi, and here's minus sine to sine phi, so this will be r square sine theta sine square phi, right? Yeah. Now this will be, now for this one, try to take like sine theta cos square phi common. If you take over here sine theta cos square phi common, this will just be sine square theta plus cos square theta, right? And over here we have r square sine theta sine square phi, and we again know this is 1, so this is r square sine theta cos square phi plus r square sine theta sine square phi, right? Now again, if you take r square sine theta common, cos square phi plus sin square phi is going to be 1. So this is r square sine theta. Guys, I knew that this was going to happen, because I already knew that like a dx dy dz is just rho square sine phi d rho d phi d theta. This is just in the dB of spherical coordinates. So from there I knew it was going to simplify, so that's why I did this. Okay, so now you also know this, like you also know that this matrix's determinant is going to simplify, and then that's a good thing for us. So yeah, however bad it may seem, it's not always that bad, right? Okay, now this is r square sine theta, right? Now, okay, now I guess you know how to find like matrix inverse, right? So what we do is for every, like, okay, I'll just show you. So first of all, 1 by determinant, which is r square sine theta. Now after that, now for the element in this over here, that will just be um the determinant of these four, I mean determinant of these four terms, right? And then there will be a sign, or there will also be a sign associated with position, which is plus minus plus minus plus minus plus minus plus, right? And yeah, and at last you also need to take a transpose, so there are a lot of things to do, right? Okay, shall I go it as like one by one form? I should go with in the way the textbook does this, because that's more like process wise. Okay, I'll do that. Okay, first of all, okay, so first of all, if you like, let's number them. This is called A11, right? And then for the first row, second column, this is A12, A13, A21, A22, A23, A31, A32, A33. So first of all, we try to find cofactor, right? Now, cofactor of A11 will just be, so here there will be negative sign, right? As I already told you, there will be, I mean, oh sorry, positive sign. So plus minus plus minus plus minus plus minus plus, right? This is the sign. Basically, to find the sign, what you can just do is raise -1 to the power of its location. So -1 to the power its location right now is 1 1. So 1 plus 1 2. The sum of the location. So yeah, the location is 1 plus 1 2. So yeah, you can raise that to the power. That's a good way. Yeah. Now if we do this, would that always work? Yeah, it will always work. Okay, now fine. So yeah, this will be positive anyway. Now after this, for cofactor, find determinant of this other terms. I mean these ones. I mean, what you need to do is just ignore this row and column that it's in, and find the determinant of all the remaining elements. Okay, that's how we do it. So this will be r cos theta sine phi, r sine theta cos phi, minus r sine theta 0, right? That would take a long time. Yeah. Now this is just positive one, and this is r square sine square theta, r square sine square theta cos phi, right? Okay, we got this. Now cofactor of 1 2. cofactor. This will take a lot of time. I just don't want to do this. I want to write it directly here, guys. I'm gonna write it directly. This is going to take a lot of time. I don't want a lot of time to be spent. I will write it directly, guys. I guess now you have the idea what to do, right? Because this will take a lot of time. I don't want to spend a lot of time in this. Okay. So if I do it directly, so first of all, for this cofactor, there will be positive sign times and determinant of these four elements, which I already told that it's just r square sine square theta cos phi, right? And then for okay, now I will just ignore since now this turn of this element, I will just ignore this row and this column, right? And I will determinant of all the others remaining. The determinant will just be this is 0 minus r sine theta cos theta sine phi. So mine, and also that there will be minus, but also this place has a minus sign. There will be so two minus. This is the minus of the place, and that's minus is from determinant. So minus r sine theta cos phi, right? This becomes plus eventually. Now over here we have minus. Oh wait, and I also forgot this thing that was there in the place originally. Okay, so this will now be uh, this is boring here. Okay, now this will just be minus r cos theta cos phi times the determinant is minus r sine theta cos phi, right? Okay, for third one this will just be minus r sine theta sine phi times, and I also need to remember that there's a determinant in front. There's a 1 by determinant in front. Okay, now minus the 175 times, that will just be, what the hell, minus r sine square theta sine phi minus r cos square theta sine phi. So that means minus r sine phi only. Minus r sine phi only. Okay, wow, that was nice. Next one. Okay, so now here it was plus sign, so it doesn't matter. Now it is minus sign, yeah. Now here is minus sign, right? So minus sine theta sine phi. There's even no space actually. So to make this space, what I can do actually is I can just move this slightly to the side. Okay, yeah, I think now it makes sense. Also move this slightly. Guys, this is so boring, yeah, guys. Okay, now this is minus sine to sine phi times determinant will be, we will just ignore this like row and column that it's in, and yeah, this is just 0 and this is just minus cancels, minus r square sine square theta sine phi, right? This will just be minus is from determinant, minus r square sine square theta sine phi. Okay, good. This one there will be plus sign, so just r cos theta sine phi and then 0 and then plus r sine theta cos phi, r sine theta cos theta sine to cos sine phi. And this one will just be first of all r sine theta cos phi. Now this has negative sign, right? This is the sign of the place, minus r sine theta cos phi times, whoa, I need to do it faster, minus r sine theta cos phi times, this is now again that is minus r sine theta cos phi minus r, oh wow, that simplifies, right? So that's just minus, okay, so that's just minus r cos phi, good, minus r cos phi. This one, oh wow, now this is a bit easy, I guess. Again, this has plus sign, so just cos theta, and cos theta, and then now I just need to ignore the row and column of this. So determinant of the remaining things, right? Which is just r square sin theta cos square phi plus r square sin cos theta sin square phi. So this is just r square sin theta cos theta, and with minus r sin theta, and again this has minus sign, that's that will be plus. So plus r sin theta, and this is r sin square theta cos square phi plus r sin square phi. So this will just be r sin square theta only, right? Cos square phi plus sin square phi is 1. Now this is 0, so 0. Wow. And there's determinant. Now also I need to take transpose of this to find inverse, right? I guess you guys know this. And now determinant is just r square sin phi. Everywhere there's r square, I will cancel that. And also sin theta. Is it everywhere sin theta? Yes, it's everywhere. I will cancel that as well. Man, it's going down so fast. I cannot let this video go down. So what I can do is I'll just, okay guys, I need to use a technique now. I'll just charge this iPad because I cannot let this video go down, because don't I mean I have spent a lot of energy on this, right? So I can definitely, yes. Fine. Is the speaker working? Yeah, good. Okay. Now, okay, so let's divide by r square sin theta to all of these elements, and then we'll take transpose. So that will just become cos phi, and okay, that will just become cos phi. What will this become? R square sin theta. If I remove that, we will still have cos square theta cos square phi. That's a lot there. Now if I remove, that's just sin square phi, right? Yeah, and that's just r square theta sin r square sin theta, right? I will still have a lot. Sin square theta sin square phi. Over here I will have, if I remove r square sin theta, I will have cos square theta sin square phi, right? Yeah. Over here, if I, okay, yeah. If I remove r square sin theta, I will have cos square phi. I will have 0. If I remove r square sin theta, I will have sin square theta. I will have cos square theta. Now if I take the transpose, these are so good, yeah. I mean, they're so, symmetric about cos and sine, right? That looks so good. Now take a transpose, so that it will now be cos phi, cos square theta, cos square phi, sin square phi. Now this will just be sin square theta, sin square phi, cos square theta, cosine square phi. Now that's just cos square phi, cos square theta, sin square theta, 0. Guys, does this answer maths? I don't know. Why does it look like it doesn't, huh? Okay, let me just open my laptop and check the answers. Okay. Okay, guys, why doesn't it even maths? It doesn't math, right? Guys, it should match, guys. I don't know. If it's not matching, that's not my fault. I don't know. I don't know whose fault is it. Guys, was there r cube instead of? Everywhere it's just okay. Yeah, this should work. I don't know. Okay, now we know that this is just. But it's clearly not working. How should this work? Okay, and we know that this should be equals to partial r by partial x, partial r by partial y, partial r by partial z, right? and then partial theta by partial x, partial theta by partial y, partial theta by partial z, partial phi by partial x, partial phi by partial y, partial phi by partial z. If you make that comparison, we are definitely not getting the right stuffs. Hey guys, even though this is not working, I don't know why this is not working. But I'll just give you the proof. So yeah. If you can solve it this way, right? But I'll just give you the proof so that you will agree with me, and that's enough for me. Even though this is not working, it doesn't matter. What's the proof of this? That's the I've been saying. Now if you know the multivariable chain rule, right? If you know the multivariable chain rule, then we know that let's say if x is a function of r theta phi, right? If y is function of r theta phi, if z is also function of, let's say, r theta phi, right? In that case, let's say if you want to find change in z due to r theta phi, this will just be the partial change in z due to change in r, the partial change in z due to change in theta, and partial change in, this is not z, this is x, partial change in x due to phi, right? Yeah. Similarly, if you want to find change in y due to r theta phi, that will just be partial change in y due to r, partial change in y due to theta, and partial change in y due to phi, right? Similarly, if you want to get change in z due to r theta phi, partial change in z due to r, partial change in z due to theta, partial change in z due to phi. So total change is just the sum of the partial changes, right? If you want to write this in matrix form, this will just be equals to dx dy dz. It's same as the matrix of partial x by partial r, partial x by partial theta, partial x by partial phi, right? And then partial y by partial r, partial y by partial theta, partial y by partial phi, right? And then partial z by partial r, partial z by partial theta, partial z by partial phi, times dr d theta d phi. So we got this, right? Okay, now similarly, if you look at from a different perspective, if you look at from different perspective, say, let us say that again, we also know that we can write as r being a function of x, y, z, theta also being a function of x, y, z, phi also being a function of x, y, z, right? We can see it in that way, right? If we see it in this way, and now if I try to find total change in r due to x, y, z, I can write this as change in r due to x, change in r due to y, and change in r due to z, right? Similarly, the change in theta can be written as change in theta due to x, change in theta due to y, change in theta due to z, right? Similarly, I can write the change in phi as change in phi due to x, change in phi due to y, change in phi due to z, right? Now again, if I write this in matrix form, I will get the vector dr d theta d phi as partial r by partial x, partial r by partial y, partial r by partial z, partial theta by partial x, partial theta by partial y, partial theta by partial z, partial phi by partial x, partial phi by partial y, partial phi by partial z, times dx dy dz, right? Now if you want to isolate dx dy dz just like over here and take it to other side, this will just be dx dy dz will be equal to, if it goes to other side, that will be inverse, right? Partial r by partial x, partial r by partial y, partial r by partial z, partial theta by partial x, partial theta by partial y, partial theta by partial z, partial phi by partial x, partial phi by partial y, partial phi by partial z, inverse of this, times dr, d theta, d phi, right? Now you might notice that these two are actually same. These two are actually same. In both of them, we are trying to find xyz using r theta phi, right? So these two matrix must be same, and that's what the proof is. So if the matrix must be same, now we definitely get that this partial x by partial r, partial x by partial theta, partial x by partial phi, partial y by partial r, partial y by partial theta, partial y by partial phi, partial z by partial r, partial z by partial theta, partial z by partial phi. This is just equal to the inverse of partial r by partial x, partial r by partial y, partial r by partial z, partial theta by partial x, partial theta by partial y, partial theta by partial z, partial phi by partial x, partial phi by partial y, partial phi by partial z. And that's what proves what I said earlier. Guys, now I have proved it, right? Then that means it should be true. I don't really know why didn't this work. This should work. Yeah, guys, you believe me, right? Even if you don't believe me, you should believe math, right? I don't know. I just don't know. I just don't know. Guys, maybe there are some errors. Try to find out and make it work. So yeah, I definitely give you a solution. So you can just write it. Right, you can just be like, you can just be, you know what, convinced with this first solution, even the second didn't work out. And I also give you a proof, so you can convince that this method works. So that's it for this video. Doesn't need that everything needs to work out, right? Because life's unfair. Okay, that's it, guys, and look forward to seeing you in the upcoming videos too.